All right, let's see another example from section 10.3 about polar coordinates. This example asks us to find the slope of the tangent line. Our function is r equals 9 plus 4 cosine theta, and we want to find that slope when theta equals pi over 3. So as a reminder, to start this, we need to remember that x equals r cosine theta and y equals r sine theta. The other thing we need to remember is what is dy dx? Well, dy dx can be found by doing dy d theta over the x d theta, just like we did with parametric equations in section 10.2. So here, r is 9 plus 4 cosine theta. So we can actually fill that in both the x equation and the y equation. For r. So on the top, we have r times cosine theta, and for y, we have r times sine theta. This gives us an actual parametric equation for both x and y that we can now use to find the derivatives and plug in for dy dx. So we need to find the derivative of y with respect to theta and the derivative of x with respect to theta. So let's find each one of those now. We'll start with x, dx d theta, and we're going to take the derivative of x just as if it were an x and y equation. And we have two pieces, 9 plus 4 cosine theta and cosine theta. So we have a couple of choices. We can either multiply this out, or we can leave it alone and use the product rule, where the first function is 9 plus 4 cosine, and the second is just cosine. So let's go with that method, since then we don't have to actually multiply anything out first. So the product rule would tell us here that we have the first, so 9 plus 4 cosine theta. Oops, sorry. Switch back to draw. Sorry about that. Press the wrong button. 9 plus 4 cosine theta. So that's the first times the derivative of the second plus the second times the derivative of the first. So what's the derivative of 9 plus 4 cosine theta? Well, the 9 goes away and cosine becomes negative sine. So we have negative 4 sine theta. And then we can do dy d theta very similarly. We have the first times the derivative of the second plus the second times the derivative of the first, which is still negative 4 sine theta. So now we have the derivative of x with respect to theta and the derivative of y with respect to theta. So in order to find dy dx, we simply need to divide the two. So dy dx would be the derivative of y. And I'm not going to simplify anything yet. Divided by the derivative of x. Negative sine theta, negative 4 sine theta. Okay, so we have an expression now for dy dx. Now here's the thing. The question only said, what's the slope of the tangent line when theta is pi over 3? So although a natural next step might seem to be simplifying this as much as possible, the only question is, what's dy dx when theta is pi over 3? So rather than doing all the work to simplify this, I can just go ahead and plug in pi over 3 for theta and find out what my answer is. If the question was more detailed than this, asking about where are all the tangents or things like that, as we've seen in previous examples, it might help us to simplify, but at this point, I really don't think there's any benefit. So let's just move forward with plugging in pi over 3 for theta. So I'm going to go to a new screen. So we have 9 plus 4 cosine theta, dy dx. 9 plus 4 cosine pi over 3 times cosine pi over 3. Bear with me, I have to go back and forth. Plus sine times negative 4 sine. Plus sine times negative 4 sine. Oops, I keep pressing the button on the pen, I apologize. So now we have all divided by. Bottom also started with r, so 9 plus 4 cosine pi over 3 times negative sine theta. And then plus cosine times negative 4 sine. Cosine times negative 4 sine. All right, so there's our full derivative written out, substituting pi over 3 for theta. So how do we finish this? Some math, duh, right? But the only two things you have to figure out are what's cosine of pi over 3 and what is sine of pi over 3. And I'm going to write those down just to help us remember. What's the cosine of pi over 3? It's 1/2. And what's the sine of pi over 3? Square root 3 over 2. Excuse me, square root 3 over 2. And make that a little more obvious there. So we need to fill in everywhere with those values. So 9 plus 4 times 1/2 times 1/2 plus square root 3 over 2 times negative 4 square root 3 over 2 for the numerator. And for the denominator, we have 9 plus 4 times 1/2 times negative square root 3 over 2 plus 1/2 times negative 4 square root 3 over 2. Okay, so even though this looks really horrible probably to you, we're done. We just need to simplify this all the way down to something that is, one single fraction, not a bunch of addition and multiplication. So I'm going to spare you a little bit of that, and I would like you to try that on your own. And instead, I'm going to give you the final answer so you can make sure that all of your math is correct here. This works out to be the square root of 3 times negative 5 over 39. All right, so obviously that's not a nice number that you can write down without rounding something. So in order to keep the answer exact, this would be a proper answer. Or if you didn't want to separate the square root out, this could also be written as negative 5 square root 3 over 39. So what did we just find? The tangent, what was the question? We found the slope of the tangent line when theta is pi over 3. So to finish this example, you should graph the original function and look at the curve when theta is pi over 3, and hopefully this answer will make a lot more sense. This is a negative number, less than 1, so it's got a negative slope, and it's very shallow, I guess would be the right word. So make sure to check this on your calculator. And let me open, or yeah, you can do that yourself. You can check this on your calculator by making sure your mode is in polar mode and graphing 9 plus 4 cosine theta, and then tracing on the graph to where theta is pi over 3. Okay? Thanks for watching.